today's video, we are going to discuss about classful addressing. Now, let's begin with first of all, what is classful addressing? So, classful addressing is a method of the IP address assignment. Now, in classful addressing, the IP addresses are assigned, and it was used in the early days of internet. And in classful addressing, the IP addresses are divided into basically the predefined classes. Uh, there are five predefined classes nowadays that are class A to class E, but there were primarily three classes only: class A, class B, and class C. And each of the class has a fixed number of bits that are assigned for the network portion and the host portion of the IP address. We'll talk more on that later. Now, let's talk about the IP addressing, short form for Internet Protocol Addressing is basically the assignment of the numerical labels to the device that is present in a network and which uses the internet as a mode of communication. Now, the main purpose of IP are to provide location of the devices within the network and to identify the host in the network. Now, there are two versions of IP addresses. It's either IPv4, Internet Protocol version 4, or Internet Protocol version 6. Now, IPv4 addresses are 32 bits binary numbers and they are represented in human readable decimal formats. Now, in IPv4, we have octets which are of 8 bits, and there are 4 octets in each IPv4 that gives us a 32 binary bit number representation. Okay, now each octet can vary from 0 to 255. That is because there are 8 octets that gives us the power of 2 to the power 8, which is 256. So ultimately, 256 is 0 and 256 both inclusive. Now, with this, it gives us a total of 4.3 billion unique IP addresses. But why we need IPv6 is because these 4.3 billion unique IP addresses were almost on the verge of distinguishness because addresses are already assigned and there is a growing demand for end devices. Now, IPv6 addresses are 128 binary bit. On the other hand, IPv4 are 32, and this is 128 bit, and they are represented in hexadecimal format. And there are 8 groups that are separated in basically in 4 hexadecimal digit, 8 groups of 4 hexadecimal digit separated through columns. It was basically designed to address the limitation of IPv4 by providing it provides a larger address space and is capable of accommodating almost infinite number of user addresses as it is so large and it is also hexadecimal. Now we'll talk about class A. Class A is one of the 5 classes of IP addresses and is basically designated to designed for large organization and cause it's suitable for them as it has an extensive range of available addresses. Now I'll talk about it more with the help of my board. Yeah, so this is the board. As it is IPv4, there are 8 bits. So these are the 8 bits, 4 octets, each of 8 bits. Now the first octet is only designated for the network ID, and the rest are for the host ID. This octet, the first octet, as you can see, is designated for the network ID. And to how do we get to know that this is class A? So to get to know that this is class A, the first bit in the first octet is reserved as 0. So this 0 bit is reserved. That means that this is class A. That leaves us with the 7 bits of 2 each. Now, so that leaves us with 2 to the power 7. That is equal to 128. Okay. So 128 uh, number of networks can be there, but this is not the case as it has to be 128 minus 2. Reason being, I'll tell you the reason. Reason is this. Now, for example, uh, as it is 0, we can't change it. But what if all are zeros? So we can't even calculate 0000. Okay, that won't be feasible. And the next is 0 and all ones. That will leave us with 128 and it is reserved for broadcast message. So that's why it is the two IP addresses are not used. So this leaves us with 128 minus 2, that is 126 number of network IDs. Okay, now number of host IDs. So the host possible number of hosts possible is 126. These are the for every different host IDs, the number of hosts can be the network IDs that are present. So it is 128 minus 2 is 126. Okay. Now if 32 minus 8 is 24, so these 24 bits gives us the rest of the host IDs, that is 2 to the power 28, and again that leaves us with the number of host IDs, which is 2 to the power 24. I'm sorry, it is 2 to the power 24. Now uh, let's discuss the range of this reserved bit after the reserved bit. Okay, so as it is a reserved bit, we are only left with 2 to the power 8, that is 2 to the power 7, that is 128. And if we include the 0 also, this gives us the range of 0 to 127. So an easy way to identify class A is that if any IP address starts from this number, it is either 0 or not 0, but 0 to 27, 127. Okay. Now, now this representation is called a dotted decimal representation. Now, for example, this 62.0.0.0, this won't be used as all the as this represents the whole network. We can't use it as this is the network ID for that particular network, and this is the host network. So basically the host network tells that if I send a message, this is a broadcast network, basically broadcast IP. If I send a message over this IP, it will be translated. It will be transmitted to all the basically PCs connected in the same IP. So if I'm connected with 62.1.0 point something, then if I send the message on 62.255.255.258, then I will also receive it. Now let's take an example of 64.0.0.2. How to know that is this IP available in this particular class or not? Now talking about class A, we'll basically calculate the subnet and we'll do an AND operator on it. What we'll do an AND operator on it. 255.0.0, we'll do an AND operator in 64.0.0.2 to decimal is basically 0 1 less 0, and at the end in the last octet 1 0. Okay, and 255 is all ones, 0 0 are 0 0. If we calculate the AND, 0 and 0 gives us 0 only. 1 and 1 and is 1. And 0 and 1 and is 0 again. So, leaving us with 64.0.0. So, then we can know that, okay, 64.0.02 is a part of this network only, 64.0.0. Correct? Now, let us discuss about class B. So, in class B, the first two octaves, which is this one and this one, are basically designated for the network ID. Now these are for network, okay, and the rest two are for the host ID. The rest two awkwards are basically separated for the host ID. In the class B, we have the first two bits of the first octet reserved as a prefix for the class B to tell that this is class B. Now, if we want to say that this is class B, then what would be the range? Now, either it can be 1 0 and all the rest can be 0, okay, or either it can be 1 0 and all the rest can be 1, correct? Now, that gives us the range. Now, 1 and all 7 0, 1 0 and uh, all six ones. That leaves us with 128, and this leaves us with 129. Now, if any range in between these numbers, both inclusive, we'll get to know that this is the IP of the class B. For example, 171 is an example of class B. Now, if these two bits are reserved, what can be the number of address possible? Now, 32 is there, the present number. 32 minus 2 particularly leaves us with 30, correct? Now that is the number of bits we are left with. Then that is the number of addresses we are left with. That is 2 to the power 30. Talking about the others, the host address is there, which is basically 2 to the power 16. How many different host IDs can be there? Is 2 to the power 16 minus 2. Minus 2 because of again it can either be 0, whole can be 0, or whole can be 255. Now, 255 is for the broadcast, and 00 depicts the whole network. And the number of network IDs are 2 to the power 14. Why 14? Because again, for 2 octets, 60 minus 2 is 2 to the power 14, that is 163.84. Now, obviously, the first range would be, if I clear this out, I write all these as 1 and the rest as 00. And the last would be, if I take all these as ones and all these two as ones. So it is 255 and 255. That is for the broadcast. Okay. Now let us move to the class C. Now this is the class C. Now there is a catch in here. I'll quickly go through it. It's similar to other networks. Now in class C, we have the first three bits. The first three bits are saved for, are reserved to depict the class C, and it gives us the range from 192 to 223. Why 192 to 223? Because uh, it is 101, and the rest as again zeros, or the rest as again ones. Correct? That if we convert the decimal into binary, we are left with 192 to 223 range. Now in class C, the first three octets, not one as in case of class A, not two as in case of class B. The first three octets are left for the network ID. Okay, the first three are left for the network ID, and the last octet is left for the host ID. Now, if we calculate the number of networks possible if we calculate the number of networks possible in class C, what it would be? Now, it would basically 2 to the power. Now, this, let us calculate it. Now, the number of network possible will be 2 to the power 21. Why? Because these are the three bits, three octets that are designated for the network ID. That is 24. Now 24 minus 3 is 10. 24 minus 3 for 10 and 1 leaves us with 21. Okay, it is approximately, if I calculate it, gives it's more than 20 lakhs. And the number of host, what is okay? And what would be the number of host possible if I calculate that? The number of host possible would be, in each network, would be 254. Why? Because it is 8. This is an 8 bit, right? Now in 8 bits, either they can be 0, or either they can be 1 each, leaves us with 0 and 1. Again, we don't use the zeroth one, and we don't use the all ones one. Okay, that's the 255 one, all ones, because ones are for the broadcast and zeros are for the basically representing the network. Thank you. This is up for my video. I hope you liked it and you enjoyed what you studied. Thank you.